Okay, when I tell you to know definitions, I would just say something like define. Define x-intercept. And I expect you to say, because we talked about definitions in class, that's the point where the graph crosses the x-intercept. So you need to know definitions for like function, one-to-one function, domain, range, x-intercept, y-intercept, even function, odd function, absolute value. I think that's the main ones that we talked about. So do make sure you know your definitions. Now, one of your definitions on test 2 will probably be continuity. Okay? So like on that video, it told you that a function, f of x is continuous at a point, like x equals, your book puts c. C is just a number. Now, IFF, I do know how to spell. Okay, IFF in math means if and only if. Okay, you got to check 3 things. The first thing that's got to be true is the limit at that point has to exist. In other words, you have to get a number. Then f exactly at that point exists, and then these 2 answers match. So the answer to the first one has got to be exactly the same as the answer to the second. And so you check all 3 parts until all 3 parts check, and you can say all 3 parts check. So it is continuous at x equals 2 or whatever. Or when one of these is false, you can stop. So you don't have to check the limit before you check f of c. If you see when you glance that f of c is not going to exist, go do it first and save yourself some time. Okay. Now I gave you some homework on page 104, correct? I need to work at least one of those so you can see how I would want it written. So does anybody have a preference about which one? Look and see. Does anybody have a preference about which one I work?
55.
55 it is. Okay. All right, so on 55, this was your function. F of x is the natural log of x plus 1, sometimes. And sometimes your function is f of x equals 1 minus x squared. Now, how do you know which one is which? It gives you some conditions. It says it's the top one if x is greater than or equal to 0, and it's the bottom one if x is less than 0. Okay, so did we copy it down right? And I believe I asked you to check continuity at 0, didn't I? All right, so I would say something like, is this function continuous at x equals 0? And it will say on your second test, prove your answer using the definition. All right, so again, I've got to check 3 things. I've got to check the limit of f of x as x approaches what number? I'm checking continuity at what? 0. Now, I've already got a problem. I don't know what to put for f of x. I don't know whether to put this log thing or this squared thing. So I'm going to have to do both. I'm going to have to do like an A and a B. Now, what do I mean by that? I'm going to have to approach 0 from the left side, and then I'm going to have to approach 0 from the right side. Now, if you're a visual learner, you may need to, in your mind or on paper, think about a number line. If I'm on the left side of 0, that means I'm over here. Am I bigger than 0 or smaller than 0 if I'm on the left side? Smaller. Okay, which piece do I use when x is smaller than 0? The top one or the bottom one? The bottom one. So now I've got to put in 1 minus x squared right here. So again, when you're doing a limit, what's the first thing you try? You try to take that number and just what? plug it in. So I'm gonna try to take 0 and plug it in for x. So 1 minus 0 squared. What's that end up being? All right, now I've got to approach 0 from the right. So if I'm on the right side of 0, now I'm over here. So now I'm not smaller than 0, I'm what? I'm bigger than 0. So what piece do I look at when I'm bigger than 0? It's what? It's that piece. Natural log of x plus 1. Now I take 0 and try to plug it in. So I get the natural log of 0 plus 1. So that's the natural log of 1. Now you shouldn't need a calculator, but you've got one. What is the natural log of 1? 0. So the left-hand limit is 1 and the right-hand limit is 0. So what does that mean about the general limit? What do we put? Does what? Not exist. Now do I keep going or stop? I stop. So I can stop and say, therefore, f of x is not continuous at x equals 0. I run out of room because the limit doesn't exist. Now, what if these had matched? What if this had been 1 and that had been 1? Then this answer would have been what? 1. Then I would have gone to the second part. Now, by the way, if you wanted to do f at 0, would you plug it in just the top, just the bottom, or both? Just the top, because f at 0 means x is exactly 0. And the only time you use, when it's greater than 0, you use this, or when it's exactly 0, you what? You use that. Okay? And again, I would get an answer. All right? If I didn't get an answer, I'd stop and say, there's no continuity because f of 0 doesn't exist. If I got answers for both, I'd check to see if they match. 1 equals 1, check. The function's continuous. Or if this answer is 1 and that answer is 0, I'd say 1 doesn't equal 0, therefore the limit what? Therefore the function is not continuous. So you've got to check all 3 parts until all 3 parts check, or until one of them doesn't check. Okay? So in your second test, that's the way you'll check for continuity. Okay? So does anybody need to see another one of those work, or do we feel okay about those? Feel okay about continuity? Now, when you're looking at the graph, do you understand then that if a function is continuous, that means that you can draw without picking your pencil up? Because think of these on the video. If you had a graph that looks like this, and there was a hole in it, and then it went on, and this was C. Is this function continuous at C? Can I draw this whole graph without picking up my pencil? So I know it's not continuous. What part blows up? The second, f of C, what? Doesn't exist. All right, what if instead it would look like this? Does f of C exist now? It's this thing, right? So if this was like a 1 and this was like a 2, do you understand that f of C looks like it's about what? 1.92. I get some answer. Well, what about the limit of f of x as x approaches C? That looks more like what? 1. So what's the problem? Not the second part, but the what? The third part. This answer and this answer what? They don't match. So it's not continuous. Question, Kevin?
Can you maybe do another example of applying the intermediate value theorem?
Sure, all right. If you're doing the intermediate value theorem, all you're really doing on that one is it's what we call an existence theorem. So when they say verify that it works and then do something with it, here's what they're wanting you to do. Look on page 101. First of all, the function's got to be continuous. And f of A cannot be what? The same thing as what? F of B. So there's 2 basic conditions for the intermediate value theorem. Right, condition 1, F is continuous. Now you might have to graph it to see. Is everybody with me? And F of A can't be the same thing as F of B. All right, so like on problem, say 99 on page 105, it says, verify that the intermediate value theorem applies. Okay? Here's your function. It says that you've got x squared plus x minus 1 on the interval from 0 to 5. Now, this is a polynomial. If you do your reading, it tells you that polynomials are continuous everywhere. So I know it's continuous, it's a polynomial. Now, what's my A right here? Does everybody understand that my A is what number? 0, and my B is what? 5. So my other condition is that F of A can't be the same thing as F of B. So I'm going to have to do F of 0, and I'm going to have to do F of 5. So what does F of 0 mean for me to do? Wherever there's an X, what am I going to put in place of it? 0, right? So I've got 0 squared plus 0 minus 1. So what does F of 0 come out to be? What is it? -1. Now I've got to do F of 5. Now you got the calculator. So now 5 goes in for X. So I've got 5 squared plus 5 minus 1. So what's 5 squared? 25 plus 1 plus 5 more is what? 30, and then minus 1 is going to give me what? 29. So we verified that this thing is continuous on here because it's continuous everywhere. We verified that F of A and F of B are what? They're not the same. So that's the first thing it said, verify that the theorem applies. Then it says, find the value of C guaranteed by the theorem. Now, what does the theorem say? So the directions continue to say, find C so that F of C is 11. Now, do you understand that this is an X value? So here's what it's saying. You're graphing this thing. When you plug in 0, the point 0, -1 is on your graph. And the point 5, what? 29 is on your graph. So, understand that these are Y values. Do we understand that these are what? Aren't those X values? So look what it says. It wants to know where your Y value is what? 11. Isn't 11 somewhere between -1 and what? 29. Well, then you know the X that you plug in to get it's got to be somewhere between what? 0 and what? 5. But the theorem doesn't help you find it. You just have to plug and chug. In other words, I need to know when the Y value is 11. Okay, how do you get the Y value? Here's how you get the Y value. The Y value is X squared plus X what? Minus 1. So when is X squared plus X minus 1 equal to 11? Well, that's a quadratic equation. That can be on your test on Thursday. How do we solve quadratic equations? Don't we pull everything to one side? So that's going to be X squared plus X. Now, when I pull that out, it's going to be minus 11 or plus 11. So that's going to be minus 1 minus 11 more is a minus what? 12. So how do we solve? Now, remember, these are much easier. Quadratic inequalities, you have to use a split point table. But quadratic equations, I can just factor and I'm set. So that's going to factor. All right. I've got to think about if I've got a minus in front of the number, one's a plus and one's a what? A minus. And I start thinking about all the things that multiply together give me 12. 1 times 12, what else? 2 and what? What else? 3 and 4. Now, because these signs are different, I'm gonna subtracting those inner terms, and I'm trying to get a positive 1. So which pair differ by 1? So 3 and 4. I need the answer to end up being positive, so I need the bigger one behind the plus. And then double check and make sure if I'm wrong, I can switch them. Always double check. So that's x squared, that's gonna be minus 3x plus 4x. Wouldn't that be a plus positive x? And that would give me a minus 12, so I know I factored it correctly. So if I multiply two numbers, I know the answer is 0. I either know the first number was 0 or what? The second number was 0. So when is x plus 4 0? When x is a what? -4. When is this 0? When x is what? 3. All the intermediate value theorem says is at least one of those should be a number between what? 0 and 5. It is one of them between 0 and 5. Yeah, it helped me find it though. I just made sure it was there before I went to look for it. So it doesn't say that all the values are there. It says at least what? At least one number. Or anything else about the review or your homework or anything up to this point before we start the new stuff. Okay, now, is continuity on your test Thursday? No. We're about to do something called a derivative. Is that going to be on your test Thursday? No. Now, there are two big ideas in Cal 1. The first big idea in Cal 1 is limit. The second big idea in Cal 1 is derivative. So we're going to do derivative using the definition today. Then you'll take your test on Thursday, and next week I'll give you some rules so that you don't have to keep using the definition all the time. All right, just like we kind of do with limit. All right, so, and we will do derivatives till the end of the semester, basically. So test 2 is mostly going to be finding derivatives, and test 3 is going to be applying derivatives. Okay, now, they kind of show this in your book in chapter 3. So you're in that very first section of chapter 3. Now, let's see if this makes sense to you. All right. If I had a graph that looked like, just like, I don't know, like this, okay? Now, if I went and drew that red line right there, how many places does that red line intersect that blue curve? In 2. Now, when you were in geometry, you only did this with circles. All right, so I'm going to call that X. Now, that means this point would be X, and then whatever you got when you stuck that X in a function. So that's F, X, F of X. Now, I'm going to move over to like here. Now, let me ask you this. What if this was 2, and I moved over 3 more spaces? What would that make that number? That's a question. It'd make it 5. What'd you do with these two things to get that? You took where you started and added the change, right? So what if I tell you that this distance right here is H? I'm going to move over H. Then what's that going to make this number right here? Think about what you did. What did you do with the 2 and the 3?
X plus H.
So this is going to be X plus H. Very good. So what's this point going to be? Well, it's going to be X plus H. And then how would you get the Y value? What would you do with this one? When you plug it into your function, so that'd be F of X plus H. Now, doesn't that red line have a slope? Don't all lines have a slope? The only one that doesn't have a slope is a vertical line. And we just say that slope is undefined. Now, how do you find the slope of any line? So I'm gonna put slope of the red line. I'm gonna change that in a second. How do you find the slope of any line? What's your little formula that you have on your test Thursday for slope? Y2 minus what? Y1 over what? X2 minus X1. All right, so look at your points. What's your Y2 in this one? What's my second Y value? F of X plus H. Minus, what's my Y1? It would be what? F of X. Over. All right, what's my X2? What's my second X? X plus what? H. Minus, what's your X1? All right, so that bottom simplifies a little bit. What goes out on the bottom? The x's, so I get F of X plus H minus F of X all over what? H. Now, when you were in high school geometry in 9th grade or whatever grade you took geometry in, you only did it to circles. There were two words that you should have been familiar with at some point in geometry. Sometimes a circle just clips, a line just clips a circle in one point. Sometimes it clips it in 2 points. You know what you call it when it clips it in 1 point? Most people remember that one. What's that one? It's a tangent. Do you know what it is when it clips it in 2 points? That's a secant. So do you understand, is this red line a secant or a tangent on this blue curve? It's a what? A secant. So this is the slope of a secant line. So I need you to understand that first. All right, so is everybody tracking with me so far? Now, here's what I need you to use your imagination a little bit. I want you to imagine this second point is movable. So I can take that point and I can move it up the curve or I can move it down the curve. So if I start moving this point down the curve, if I move it down to there, I'm going to have a different red line or a different secant line, aren't I? Is the slope going to be the same or different? It's going to be what? Different. As I move this point down this curve, doesn't this secant line get closer and closer? What would happen if this point was right on top of that point? If it was right on top of that point, what kind of line would I have then? It wouldn't be secant, it would be what? Tangent. Now, I want to know, how can I tell somebody I want this point to get closer and closer and closer and closer to that point? That sounds like something we've had before. What happens if something gets closer and closer and closer? What do we call that? A limit. Now, there are different ways of saying it, but I think this is the easiest one. Do you see this gap of H? What happens to H when this point comes down? What happens to this H? What's it approaching? Now, X plus H is approaching X, but H is the gap. What's the gap approaching? 0. The limit of this thing right here, about a darker marker. That would be the slope of not a secant line, but a what? Tangent line. Does that make sense to everybody? That's a derivative. That is the definition of a derivative. It looks like a formula. It's just the slope of a tangent line. Now, here's the catch. You already know how to do it because I've taught you both pieces. I've just never taught you both pieces in the same problem. That was on your algebra trig review sheet. F of x plus h minus f of x over what? H. So you already are supposed to know how to do that. Then I taught you how to do what? Limits. I just need you to do it now in the same what? Problem. So let me show you what I'm talking about. What if your f of x was x squared? Okay. Now, here's the notation for derivative. We understand it's just the slope of a what? Tangent line. All right, you know that f of x is the function itself, right? So they put f, they put, looks like an apostrophe, but it's read f prime of x. So if they say find f prime at 2. Here's what they are saying. What's the graph f of x equals x squared look like? It's just a what? It's a parabola. Let's do it different. Let's do it at 3 so you can see that you get a different answer. Okay? Now, on this graph, when x is 3, your point's right there, correct? What's the point going to be on the graph when x is 3? That's going to be the point 3 comma what? How do you get the y value right there? What does that mean? Doesn't that mean y? How do you get the y value? You do what to your x value? Here. So what's the y value right here? 9. That's the 0.39 on that picture. Here's what I want to know. I want to know if you went right there and you drew a tangent line right there to that curve. I want to know what's the slope of that green tangent line. That's what this means. So that's red, find the derivative at 3. But what it's really asking, what it's asking you is, if you went to the graph y equals x squared at when x is 3, and you drew a tangent line right there, what's the slope of that tangent line that you just drew? Well, how do I find derivatives? I use the what? This definition. So let's go use the definition and find it. Now, I do not want you to copy down necessarily what I'm about to put on the board. I want you just to watch. I know that's really hard for some of us like me. You know what I'm saying? Like, I have to write it on my paper. Okay. I will let you write it on your paper in just a minute. All right? But I'm going to show you why you don't want to do it this way. All right? So if they tell me to find the derivative at 2, all right, first of all, I write down my formula. All right, what's my formula? My formula is the limit as x approaches 0 of what? F of what? X plus h minus what? F of x all over what? H. Trying to answer that question. Now, we're not going to end up doing it this way, and I'll show you why. That's the limit as x approaches 0, f of, what's my x value that I'm worried about? 2. Now remind me, what's my x value I'm worried about? It's what? 2, all over what? H. Okay. The limit is x approaches 0. Now, help me out here. What does it mean when they tell me to find f of 2 plus h? So if, wasn't f of x, x squared? So what does f of 2 plus h mean for me to do? Everywhere I see x, what am I going to put in place of it? 2 plus h. So what am I going to put in place of that x? I'm going to put a what? 2 plus h. Now what have I got to do? I've got to square. All right, square that for me. What happens when you square the 2? You get a 4. What's my middle term going to be? How many h's? 4h. You're going to say this one times this one, and then you double it. And then plus what? H what? Squared. So do we understand that I get a 4 plus a 4h plus an h squared? That's this thing right here. All right, then it says minus, so I'm going to put minus. Now, what does f of 2 mean for me to do? F of 2 means what's x going to get replaced with? 2. So that x gets replaced with 2. So what do I get? I get what? 4. And then all that's over what? Okay. Now, does this first bracket really do me any good? So what can I do with it? Can I just drop it? Now that second bracket I got to distribute. So what's going to go out right now? My 4s. So I have the limit as x approaches 0 of 4h plus h squared over h. Now, at the very beginning, why didn't I just take 0 and start plugging in? What was the problem? Just like on your test Thursday, why can't you take 0 and just start plugging it in places? Oh, except it's not x approaching 0. Y'all got me to write it down wrong as what? H approaching 0. So I can't just start plugging in 0 for h because that bottom would go to what? So what's my first trick we talked about? Factoring. Okay, what can I factor out of that top? So when I do, I get a 4 plus a what? An h over an h. Can I divide out those h's? Okay. Now, on test 2, I'm not going to make you write me the note. On test 1, you proved to me you wrote the note, and I'll believe that you're doing it from then on. So that's going to leave me 4 plus h, and h is approaching 0. Okay. Now, so can I plug a 0 in for h? So what's 4 plus 0? 4. So here's what that means. On this same graph, instead of doing it at 3, 9, wouldn't that be the point 2, 4? Now, what's the slope of that black line? It's not a 4 because that's a 4. It's a 4 because what? This is a what? 4. Okay, here's what I want you to do. I want you to go do the derivative at 3. I want you to answer me that question. What's the slope of that lime green line over there? If you drew a tangent line at the point 3, 9, I want you to rework it. So what's your x going to be? Not 2, but what? 3. All right, so go work that one for a second. And I want to show you something. Then you can copy down something. So now I need the limit as h approaches 0 of f of 3 plus h minus f of 3 over h. x squared. So what does f of 3 plus h mean for you? Everywhere there's an x, what are you going to put in place of? 3 plus h. So that x gets replaced with a 3 plus what? 8. So what'd y'all get when you expanded that? What'd y'all get? What'd you get when you squared the 3? So a 9 plus, so how many h's? 6. And then a what? H squared. All right. What does f of 3 mean for you, dear? Where you see an x, what are you going to put in place of it? 3. So what's that x going to be replaced with? So what's that? That's going to be a 9. All over what? 8. Now, does that first bracket doing you any good? So I can just drop it off. But I've got to distribute that minus. So what's going to happen to my 9s? They're going to do what? Are they going to go out? So they subtract out to 0. So I'm left with a 6h and an h squared. Now again, why did you just start plugging 0 in for h's to start with? Because the bottom would have gone to what? 0. So what's your first trick to drop? So what can I factor out of that numerator? An h. So what's that going to leave me? A 6 plus a what? An h. Now will those h's divide out? So that's going to leave me the limit as h approaches 0 of 6 plus h. Now can I take 0 and plug it in for h? So what do I get? 6. So let's make sure we understand. So do you understand what's the slope of this green line? It's what? 6. What's the slope of that black line? It was what? 4. Now, do you understand that the point -1, 1 is on there? What if I wanted the slope right there? Wouldn't you have to work the whole problem over? Well, that's going to get old in a hurry. So that's why we're not going to do it that way. Here's what we're going to do instead. I'm going to find something called the general derivative. Here's your definition. I'm not going to plug in my number for x until the very end, not at the very beginning. So if somebody said, find the derivative at 2, find the derivative at 3, find the derivative at -1, I can work them all really once. Now this is what you were doing on the review sheet. If f of x is x squared, remind me, what does f of x plus h mean for me to do? What's this x going to get replaced with? X plus h. So that x gets replaced with what? X plus h. So expand that for me. What happens when you square x plus h? What are you going to get? X what? Squared, right? How do you get the middle term? I'm going to say this one times this one and then double it. So what's my middle term going to be? 2xh and then plus a what? H what? Squared. That's f of x plus h. Minus. Well, now what's f of x? F of x was just what? X what? Squared. All over h. Now, again, is that first bracket really doing me any good? So I just drop it off. So x squared plus 2xh plus h squared, and then minus what? What's going to happen to my x squareds? Don't they go to 0? So that's going to leave me the limit as h approaches 0 of 2xh plus h squared over h. What's my next step? Just like before, what am I going to do? Factor. What can I factor out of that top? An h. What's that going to leave me? A 2 what? 2x plus an h. Now, what will happen to those h's? Don't they divide out to 1? So I'm left with the limit as h approaches 0 of 2x plus h. Now can I plug 0 in for h? So I get 2x plus 0, which is what? 2x. Now, that is called your general derivative. The derivative of x squared is what? 2x. That will get you the slope at any x value that you want. So if the general derivative is 2x, what's the derivative going to be at 2? What did x get replaced with? 2. So what's that it's going to get replaced with? And I get what? 4. What if I wanted the derivative at 3? Then what would x get replaced with? 3. What do I get? 6. Isn't that exactly what I got over there when I do them separately? What if I wanted the slope of the tangent line at -1, like over here again? If I want the slope of that tangent line, isn't it dropping? So I know it's going to be negative, and sure enough it is. I have 2. What's my x value? So do you see the advantage of finding the general derivative and then plugging in? Then you've really only got to work the problem one time, even if they want multiple tangent line slopes. And this thing is just called the general derivative. And sometimes they'll ask you to find just the general derivative and stop. And sometimes they'll ask you to find the derivative at a certain point. Okay? Now, here's what I want you to do for me, then I want you to try this one. All right. All right. So if f of x equals 3x squared minus 5x, I want you to find me the general derivative. And use your formula. All right, remind me, what does it mean when it says f of x plus h? Everywhere there's an x, what are you gonna replace it with? X plus h. So there's an x right there, and there's an x right there. So what are those x's gonna get replaced with? X plus h. All right, so I've got a 3. Oh, wait a minute, instead of x, what am I gonna do in place of that x? I'm gonna put a what? X plus an h, but I've got to do what? I've got to square it. Minus 5. Oops, there's another x. What am I going to put in place of it? X plus h. Okay. Now, this is just 7th grade math. Do you multiply first or do exponents first when you're doing order of operations? Exponents. So I've got to square this. What happens when you square x plus h? You're going to get x what? Squared plus how many xh's? 2. And then plus a what? H squared. Then I've got to distribute that 5, so it's going to be minus 5x plus or minus 5h. Isn't that minus 5h? Then I've got to distribute that 3, so I've got a 3x squared. How many xh's now? 6. And then 3h squared. Now, will that clean up any? Can I combine anything? It's just one long nasty thing. All right, so that's my f of x plus h. I got 3x squared, 6xh, 3h squared minus 5x minus 5h. So in that bracket is f of x plus h. And then it says minus, what's supposed to go in the next bracket? F of what? F of x. Okay, what's f of x? 3x squared minus what? 5x. And all that's over what? That first bracket's not really doing me any good, so I can drop it off. 3x squared plus 6xh plus 3h squared minus 5x minus 5h. But I've got to make sure I distribute that minus, so it's going to be minus 3x squared and then plus or minus? Plus my 5x. Now, does any of that clean up? Does anything go out?
Yes.
What goes out? Right, the 3x squareds go out. Anything else?
5x's.
5x's. All right, so let's see what that leaves us. Got the limit. See, I can't lose my limit. We don't have any magic. So I've got a 6xh. I've got a 3h squared, and I've still got that minus 5h. So what's my next step? Because I can't just plug in. All right, what can I factor out of the top? An h. All right, when you factor an h out, what's that going to leave here? A 6x. What's that going to leave here? A 3h and then a minus what? 5. Well, those h's divide out. Okay. So that's going to leave me, the limit is h approaches 0 of a 6x plus a 3h minus a 5. Now can I take 0 and plug in for h and nothing terrible happens? So I've got a 6x plus a 3, there goes my 0 in for h minus 5. So what do I end up with for my final answer? 6x minus 5. That's the general derivative of that function over there. So what if they wanted the derivative at 0? What would I do next if they wanted that?
Plug a 0.
I'd plug a 0 in for what? X. If they wanted the derivative at 1/2, I plug a 1/2 in for X. If they wanted the derivative at -1/3, I plug a -1/3 in there for X. So sometimes they're asking you to just find the general derivative and stop, and sometimes they're asking you to, sometimes they'll say, find the derivative at X equals 0. Or find the derivative at the point 1, -2. Is everybody with me? These are saying the same thing. Find the general derivative, then plug in what for 0? X. Here, how do I know whether to plug in the 1 or the -2? Aren't you always plugging in the X or the Y? You're plugging in the what? The X. So what would I plug in here? 1 or -2? How do you plug it in the what? The 1. Sometimes they won't say find the derivative. They'll say find the slope of the tangent line to the curve f of x equals 3x squared minus 5x at the point 1, -2. So you've got to know what is the slope of the tangent line, a strange way of saying it, find the what? The derivative. Those are two interchangeable phrases. Find the slope of the tangent line and find the derivative are two ways to ask you to do the same thing. Okay? Now, is this going to be on your test Thursday? No. Now, I am going to put an assignment up that's not due until next Tuesday. Is everybody with me? So wait until after your test to do it. Okay? All right, I will see you on Thursday. Now, as long as you start the test on time